Alright, this is section 2.3. This is going to be basically solving right triangle trig. So you're going to have right triangles through this whole entire section, and we're going to solve them. Now, this book goes into something that I think is pretty well stupid, not going to lie. Talk about significant digits, talking about 2 significant digits nearest degree and 3 and 4 and so on. I just think that's way too confusing. So what I want to do is make a firm rule. Let's just make it 2 decimal places to the right of the decimal point. So the hundredths place, whether it's a side length, hundredths place, whether it's a an angle that you're finding, whatever the case might be. Let's just make a firm rule that it's the hundredths place. Now the problem is, when you check answers in the back of the book, if you do check answers in the back, it might not always be the same as the back. So as long as you're close, you're probably fine. It's called a rounding error. It can happen, or a rounding difference. Okay? But this is basically how this section is going to go about. You're going to give a right triangle. Okay? And it's A, B, and C. You literally can do whatever you desire. Okay? Just one of them has to be a right angle. Okay? And usually the C is the right angle. If I'm not mistaken, I didn't necessarily write that here. But I'm going to say A, B, and let's say the C is the right angle. Okay? So if we end up doing that, 40 degrees is the angle A. C is the 90, and then we'll figure out the rest. Side C, always opposite of angle C. So C, little c, is 12 centimeters. And if it says solve the triangle, you must find every missing side and every missing angle. Okay? So we are given angle A, okay, and then angle C is your 90-degree angle. The only angle missing is angle B. Okay? How are you able to find that? Hopefully you recognize, hey, this is 40, that's 90, it needs to add up to 180, so I know that B is going to be 50 degrees. So somewhere, some way, you tell me that B is 50 degrees. Alright, and then the other two will be side A is opposite angle A, and then side B. You only can solve one of them at a time. Choice is yours. Now what I usually encourage you to do is use the angle that was given. And I realize all of us are smart people and we can know that 50 degrees is an answer, but just in case you got it wrong, you know that angle A is 40 degrees. And what you need to do is decide, okay, I have angle A. I want to find either side A or side B. You choose. We'll do one of each. And then I have a side already. This is what you need. So I'm going to say, you know what, I want to find side A. Okay. I want to find A. I have angle C. So from the 40-degree angle, I have the opposite, or I want to find the opposite, and I have the hypotenuse. Opposite, hypotenuse. That goes with so and the SOHCAHTOA little analogy. So I know it's going to be sine of my angle. My angle in this problem is 40 degrees equals, what is my opposite? It's A over my hypotenuse is 12. The point of this is now I set up myself a nice little proportion I can solve. So I'm going to multiply 12 back because I want to find A. So 12 sine of 40 degrees is equal to my side A. Can you guys all multiply that together? I think so. A is going to end up being 7.71, and it's centimeters because that's my label. Okay, so that's how you find side A. You can use the exact same principle for side B, except which one do I want now? B becomes your adjacent to 40 degrees. So I'm going to say that cosine of 40. Why is that important? Because it's cosine adjacent over, use the side that's given to you. You can't go wrong. The hypotenuse. So I want the adjacent. I have the hypotenuse. That means I need to use cosine in the SOHCAHTOA. So cosine of my angle is equal to B over 12. Same principle as the last time right here. Multiply 12 to both sides. So 12 times cosine of 40 degrees is equal to, the 12's cancel, B. So B equals 9.19 centimeters. Now that's how you solve it. You have every side now. But what I want you to do, you should get in the habit of this. A is 7.71. B is 9.19. Your triangle should work. The shortest or smallest angle should go with the shortest side. Okay? The longest or the next one in line. So 50 degrees should go with the middle number, and then the largest angle better go with the longest side. So that scenario works for me. I checked it. It makes sense. I can feel comfortable moving on. Okay? Here's another right triangle. So right triangle ABC. So once again, C is your right angle. And we end up dumping in the fact of, and yes, your triangles can look as ugly as that if you really wanted to. You just label it however you want. Just make sure your C is your right angle unless they specify different. Side A, 2.73. Side B, so opposite here, 3.41. Oh my goodness, I don't know anything else. So how do you find another side? Well, if you're given two sides, the third side's easy. It's no different than you're given two angles. The third angle, you just have to add up to 180. If you have two sides, the third side, you can use Pythagorean theorem because it's a right triangle. So I'm going to say the 3.14 squared plus the 2.73 squared is equal to your C squared. So then if you do all the math, if you add those up and then take the square root, C equals 4.37. So you can either take my word for it or you can check it out yourself, but just got to do this math and then obviously take the square root. So I now have all of my possible sides. I need to find my two missing angles. So what you need to do is literally pick one of them. But once again, what I encourage you to do is use the numbers that you were given because you may go wrong here. You don't know for sure if that's correct. Yes, it's longer than the rest. You can feel pretty confident. But if you use the numbers given, you literally can't mess that up. So I want to find maybe angle A. Okay, if I want to find angle A, what two sides was I given? Okay, I have the opposite, so side A is opposite, and I was given B, which is the adjacent. So if I have opposite and I have adjacent, that goes with TOA. So I'm going to use tangent of angle A equals my opposite, which was 2.73, over my adjacent, which is 3.41. Now how do I find angle A? Hopefully you guys are thinking, hey, I need to get the angle by itself. That tangent needs to go away. How do I do that? Tangent inverse, both sides. Okay? So I end up getting A equals the tangent inverse of this fraction. So that goes back to the previous section. And tangent inverse of that, you can do that right on your calculator. So angle A equals 38 point, and I said round to the nearest hundredth, even for an angle. Okay? So angle A becomes 38.68 degrees. Now how do you find angle B? You could do the same process and do tangent of 3.41 over 2.73, but why go through all the work when you already know that 90, okay, minus this number, okay, will equal the other one. The reason I say that is 90 degrees is already soaked up here, which means that these two must also add up to 90 degrees to equal your 180 degree triangle. So if I just know that 90 are left over, 38.68 of them are used for angle A, I now know that 51.32 of the degrees are used for angle B. So I should say that B is equal to 51.32. And then once you get done solving it, just a quick check, quick glance. Here's my smallest angle, smallest side. Middle angle, middle side, largest angle, largest side. You should feel semi-confident that you got it correct. Okay? Alright, here is the difficult problem. There's going to be a little bit of writing in this. So here's where we're going to use this in class, and we're going to try to do a couple of these in class. So in the figure, I know that A to D is 32 feet. So I have this all drawn out here. So A to D is 32 feet. Alright? And then use the information to solve for X, which is the distance from D to C. So what gets difficult is you have multiple different triangles in here, and this gets brutal. So the only bonus is both of these have a right angle. Okay. Sorry, fun fact for today, my wife just called me and our hard drive on our computer at home just corrupted, so that was sweet. We just lost all of our pictures. But anyway, that can be a discussion on a different day. Here's our hard problem. So what we need to do is solve for x. Now in order to solve for x, we need to find a bunch of other information. Okay? So here's the way I kind of think about this. I'm given an angle. In order to solve for x, I need to use this side. Okay? The only way I can really get this side is if I actually know the height. And since I don't know the height, we're going to make two separate problems out of this. But I want to find a relationship of just this triangle with the height and this x. So if I use this angle I know, okay, tangent of 54 degrees is equal to this h over the x. Okay? And now what I want to do is basically use this h to my advantage, because this h is a shared side in this problem with the x, okay, and then it also is shared with this big problem, which gives me another ratio. And what we're going to do is I'm going to solve for x in both of them, or h in both of them, because it's shared. Okay, so if I look at the big triangle, all right, if I use the big one, I'm going to say that the tangent of 38 degrees this time. Okay, so tangent of 38 ends up being h over what? Okay, the bottom is 32 plus x. So what I want to do now is, since I have essentially two different scenarios, I can solve for h in both of them, and then I can set them equal to each other and basically get rid of the h's. And then I have everything in terms of numbers, because tangent of 54 is essentially just a number, and x's. And then what you end up doing is just solving for your x, which is a little bit tedious, but that's okay. So h equals x times tangent of 54 degrees. Okay? So that's the idea with this one. I solve for h. Same idea here. I'm going to multiply this guy over. So 32 plus x times tangent of 38 degrees is equal to your h. I simply just multiplied my denominator over to the other side. Now since I have equal to h in both cases, I now can set up these two equal to each other. Okay, so basically I'm going to take, okay, h equals this. So I'm going to take this guy and plug it in for h. So I'm going to say that 32 plus x times tangent of 38 degrees equals x times tangent of 54 degrees. Alright? Now here's the deal. We need to solve for x though, which means I need to get x on the same side of the equation, and this just isn't going to work having these parentheses. So we need to get rid of parentheses. 32 times tangent of 38 degrees plus x times the tangent of 38 degrees equals x times the tangent of 54 degrees. In order to solve for x, x needs to be all alone on one side. So I need to get these x's to the same side of the equation. So I'm going to subtract x tangent 38 to both sides. Okay? So I end up leaving this 32 times tangent of 38 degrees and set that equal to the original x tangent 54 that was there. And I must subtract x tangent of 38 over. And now if you notice what's in common, I now have an x in common. That's pretty neat because I now can get x all alone. And by now you guys are like, oh my god, what kind of problem are you doing? Here's a glimpse of college math. Okay? Some of these problems can take an entire page. Now how do I get x by itself? You divide this thing over. Okay, so what I'm going to do is I'm going to say, I'm going to divide this. Tangent of 54 degrees minus tangent of 38 degrees. But I need to do that to both sides. So I'm going to rewrite the same thing. I'm going to call it squiggly because I don't really want to write it again. Okay? So then x equals this over here. Okay? So I end up getting 32 times tangent of 38 degrees, and I must divide that by my squiggly. My squiggly ended up being the tangent 54 minus tangent 38. And you can do that right in your calculator. You can do the top and then you can find the bottom, and you can divide them, and it ends up being approximately to right on 42 feet. That is the sweetest problem ever right there, and a lot of you are just rolling your eyes at me right now. So we're going to work on word problems like this. We will do a couple of these in class, so be prepared for that, and I hope you all have a super day.